Notice in the last example, this brings up one of the biggest rules in probability, or two of the biggest rules in probability. And when we talk about those two rules of probability, here's what it says. The probability of an event expressed as, we write the probability as P of some event. It's always between 0 and 1. What that means is that, and we say inclusive, what that means is that if it's 0, this means that it never occurs. And if it's 1, this means that it always occurs. Rarely is there probabilities of never occurring and always occurring. But what it really tells me is that an event can never really be negative because we can't have a number that's less than 0. So there's no such thing as a negative probability. And also, that also means that an event can't be bigger than 1. And another rule we're going to develop is that all of the probabilities, such as when we did paper, rock, scissors. Remember, in paper, rock, scissors, we had the probability of a win was equal to 3/9. The probability of a tie was equal to 3/9. And the probability of a loss was equal to 3/9. When you add these events up, so when you add up 3/9 plus 3/9 plus 3/9, you get 9/9 or 1. So another rule we're going to establish that the sum of all the events will always equal 1. And if you look at the boy-girl, the probability of the boy-girl event we just did, we said the probability of 0 boys was 1/4. The probability of 2 boys, of 1 boy, was 2/4. And the probability of all boys, which is 2 boys, was 1/4. If you add up these events, 1/4 plus 1/4 plus 2/4 plus 1/4, notice they equal 1 as well. So two rules we've just established was that the first rule is that the probabilities can never be negative and never bigger than 1. And the second rule is that the sum of all the probabilities have to add to 1. And it's going to allow us to talk about our three main types of probabilities. All right. The first one we call the theoretical method. Or another way of thinking of that is, here's what should happen when you do certain things. For instance, if I flip a coin 100 times, I should get 50 heads and I should get 50 tails. If it's a fair coin. And that's because when you do it, the probability of landing heads is 1 out of 2. The probability of landing tails is 1 out of 2. If I flip it 100 times, I should get half of those should be 50, half of those should be heads, the other half should be tails. Likewise, if I play the game paper, rock, scissors 30 times, 10 of those games should be end up in a win. 10 should end up in a loss, and 10 should end up in a tie. That's because it's a 1/3 chance for each event. So what should happen is what we call the theoretical probability. And it's just the number of ways the event can occur, such as in, again, when you flip a coin or when you play paper, rock, scissors, over the total number of possible outcomes. So here's what that looks like. What is the theoretical probability of exactly 1 head when you have 2 coins? The way we do this is we make a probability tree. So we're going to flip a coin twice, basically. So when I flip the coin first time, I get either heads or tails. Next, if I flip a head, I can either get a head or a tail. If I flip a tails, I can either get a head or a tail. Outcomes, the possible outcomes are going to be head, 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 tails, tails, head, tails, tails. I want to get exactly 1 head. The probability of getting exactly 1 head, well, does this first event right here end up in exactly 1 head? No, it's 2 heads. What about here? Head, tails. Yes. What about here? Tails, heads. Yes. What about here? Tails, tails. No. So out of my total number of outcomes, which is what I'm going to calculate, total number of possible outcomes, the probability that I get exactly 1 head, we can write this out, is equal to how many events ended in exactly 1 head? 2. How many total events were there? 4. So it's equal to 2 out of 4, or if you want to reduce that to 1/2. Look at event B. Getting a 3 when you roll a 6-sided die. Well, when I roll a 6-sided die, what are the possible outcomes? I can get a 1, 2, 3, 4, 5, and 6, right? The only event I'm interested in is getting a 3 this time. So how many events end like that? So the probability of a 3 is equal to, there's only one event that ends in a 3. Out of how many total events? 6 total events. What is the probability that a random selected family with 3 children has 2 boys and 1 girl? We're going to assume that boys and girls are equally likely. So again, our first step, let's draw a tree. First child can be a boy or a girl. How many kids have I had there? I've only had one. I may have one of those, either a boy or a girl. If I have a boy, I can have a boy or a girl again. If I have a girl, I can have a boy or a girl again. This is a two-child family right now. Or a two-child family. Last event, boy, girl, boy, girl, boy, girl, boy, girl. So now this is a 3-child family, and I'm interested in finding I want to have 3 children, and for those 3 children, I has to have 2 boys and 1 girl. Well, if I write these out, I get these outcomes. I get boy, boy, boy. Follow the branch, boy, boy, girl. Follow the branch, boy, girl, boy. Follow the branch again, boy, girl, girl. So these are that's the branch where boy leads. Down to the bottom, follow the branch, girl, boy, boy. Next one is girl, boy, girl. Next one is girl, girl, boy. And then the last one is girl, girl, girl. I'm interested in those that have 3 children with 2 boys and 1 girl. So let's go circle the ones that have 2 boys and 1 girl. 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 And it looks like it's 3 out of, how many total events are there? Well, there are the probability of getting 2 boys and 1 girl. There are 3 events like that out of a total of 8 events.